Woohoo! I am live. This is Math 40, elementary algebra. This is 2.7. We are solving inequalities. And in order to solve inequalities, first we need to talk about what inequalities mean. So an inequality is any time you're saying that two things are not equal. So in other words, one is bigger and one is smaller. And so you're specifying which one is bigger and which one is smaller. To begin with, we've got an inequality sign. And basically, the rule of the inequality sign is it opens its mouth towards the big thing. Wherever the big thing is, the mouth is open. And if no one has ever drawn you a little inequality gator, then I will be the first. There's your alligator. Sometimes it has a big tongue because it's very hungry. And so this is the big meal, and it opens towards the big meal. And the little pointy end goes towards the smaller thing. So that's what we're going to be looking at in this chapter. So as you can guess, there are a lot of possibilities here, because if you pick any two numbers at random, generally speaking, they will not be equal. One will be bigger, one will be smaller. So inequalities are a really big topic. And what we're going to do is just introduce them here and just kind of get going on that. And apparently we've got a little ant who's coming to help. So I gotta give the ant flying lessons. Oh, the ant is just not gonna leave. Well, apparently we're gonna be doing ant math. There we go. Okay, so for each inequality, we're gonna talk about ways of thinking about inequality. We're going to express the solution set, A, as a graph, B, as an interval, and C in something called set builder notation, which sounds very fancy, and it is very fancy, but I'll show you it's not that complicated. So we're going to start off with this, x is greater than 5. So let me write that out in English. X is greater than 5. So that's how you pronounce that. And here I've got two lines for a graph. Now, you do not need to graph them twice. The reason I have two lines is because there are two styles. In both styles, now I believe in putting arrows at the end of my axes, at the end of my number lines. You can choose to, some people don't, but I think that they're wrong and I'm right. I'm going to start with 0. I won't always use 0. Sometimes I'll use another number, but it's a nice number. Usually the rule for number lines is you should give at least 2 values for scale. So I put in the 0 and I put in the 5. And because I'm doing 2 graphs, 2 different flavors, 2 different styles, I'm putting them right next to each other. So just so you can compare and contrast. So if x is greater than 5, then we want to color in the part of the number line that's greater than 5. So that would be all the numbers to the right of 5. So I'll do that in both of these examples. Now the book's version is if you're greater than 5, use a parenthesis, which is a single parentheses, or, and here, this is not the book, but this is a lot of people use this style. You use an open circle. I'm going to do mine slightly to the left of the 5 so you can see it on the video. This is an open circle, which means that it does not include the number 5. And we'll come down here and we'll do a closed circle for this one, and we can compare these two. So this is my graph. Next up, I need to do an interval. Basically, you can look at an interval as like a little mini graph, a little summary of the numbers involved. And in this case, the interval for this one is going to start at 5. And then you see how we keep going like that? I'm going to go all the way to infinity. I use a parenthesis on the 5 side to say it's a strictly greater than 5. So in other words, it does not include 5. Does not include So x cannot equal 5 in this case, this first one. Now this is going to be something else for number 2. But for number 1, 5 is right out. So my interval starts at 5 with a parenthesis, goes to infinity. And this basically tells you the starting and the stopping of all the possible answers. Now in this case, we've got a conceptual ending because infinity is not actually a number for mathematicians. It's just a concept. And so it means just keep going all the way to the right. So we've got the graph, we've got the interval, and the last thing is set builder notation. And set builder notation is going to look fancy if you haven't seen it before. You've seen it a little bit. Way back in chapter 1, we used set builder notation to write out the set of rational numbers. So you've seen it once. So let's go over it again. What does it look like? Well, it starts with a brace. That's a brace, which represents in English the set of all, and then I'm going to say x, and that's going to be my second part, that part green, the set of all x. This is how you pronounce it. And then there's a big line, and that line is such that. So this is where we're going to explain something about the rules. So this is the part of the commercial that would be in very small letters or very fast voice, telling you all the rules about X. And in this case, all I'm going to put in, I'm going to keep mine very simple, very streamlined, simply that X is greater than 5. I close with another brace, so I'm going to color that yellow as well. And then my 5, I'll go ahead and do the X is greater than 5. I'll do in purple. X is greater than 5. So in other words, I am using a very fancy way of saying X is greater than 5. So instead of just saying X is greater than 5, I'm saying, ooh, the set of all X such that X is greater than 5. It's kind of the inequality you would take if you were having tea with the queen. So this is a very fancy way of doing it. Now, as you go further in math, we're going to pack this full of stuff. There will be stuff on the left where the green X is. There will be stuff on the right and the purple side. That will get very long. And we'll use this as a place to put all of the rules. If there are any special considerations, if there are any certain numbers we want to look at, anything that we want to talk about, we will stuff into this set builder notation. And notice that the name is all that we're doing is building a set. So instead of writing the set, I'm building it with a description of it. So this is like the recipe for the set. And there we go. Now, when I write out these things, X is greater than 5, and then one of the two graphs, whichever is the way you like to do it best, the interval, the set builder notation, all of these things mean each other. So the goal would be for this section to get to know these so well so that if I just gave you this interval, you could come up with all the others. If I gave you the set builder notation, you could come up with the others. If I gave you the graph, you could come up with the others, etc., etc. Okay, let's go on to the second one. The second one is pronounced X is greater than or equal to 5. Okay, so let's get ready to graph. This is very similar. It's got one really important distinction. I'm going to also graph 0. I like to graph 0 and the point. And so get my blue. It is X is greater than for definitely. So these are all answers. So I'm going to color them in. I learned that you're supposed to color in the arrow as well. That may not be what everyone does, but that's what I do. Now, because it will include 5, so your X is allowed to be 5 in this case, I'm going to use a bracket. That's a bracket. Or a closed circle. Now, hopefully you've seen someone do this, but just in case you haven't, if I'm holding a pen and I keep my fist closed, the pen stays in. So the point stays in a closed circle. Let me get it straight. Oh, doing this with the mirror is hard. Okay, if I open my hand, the pen falls out. So an open circle means the point falls out. 5 is not included. Here, this is called a closed circle, which means 5 is included. So could you let x equal 5 here? Yes, that is one of the possible answers. Could x be 6? Sure, it's over here. That is included. Could x be 5 or 3? No, that's not part of it. It has to be bigger than 5 or equal to 5. Okay, so then what changes with the interval? Well, for our interval, my interval is going to start at 5, just like it did before, and go all the way to infinity, just like it did before. And again, a reminder, infinity, not really a point, a concept. It means it just keeps going and going and going. But notice the difference in the intervals. This interval has a bracket. That means the 5 stays there. So if I happen to have any blank paper, I will draw you a little picture. I don't have blank paper, so I'll just do it on a card. So basically, if I have a parenthesis and I have a 5 trying to stand, so if I imagine my 5 has feet, that's kind of weird. My 5 has feet, and I'll put little eyes and little hands. The problem is, if you try to stand on something like that, you go flying out. Oh no, 5 falls out. But if I have a bracket, can you stand on a bracket? Absolutely. So this 5 is really happy because it's got a place to stand. This 5, well, maybe having a good time. I don't know. But I think it's surprised. It's like, whee, it falls out. So 5 falls out, 5 stays in. So this is going to be the x is greater than or equal to 5. And this is going to be the x is strictly greater than 5. 5 is included. 5 is not included. There you go. So, and I will put that in the notes as well. If you want to screen grab that. I don't know if there's an easy place to put it so it doesn't kind of sit in front of other stuff. But so basically that's the distinction. The parenthesis, you fly right out. The bracket, you stand up. Woohoo. Okay. So that's the first page. Yay. Let's do the next page. Yay. Okay. So these are now the smaller side of things. Come over to the smaller side of math. Again, my graphs will always have arrows because that is the right way to do it. If someone says you don't need arrows, just smile politely. You don't have to tell them they're wrong. You and I will know that they're wrong, but you don't have to worry about telling them. They can just be wrong. Okay, so if I want, let me write it out in English. This says x is less than 5. And that means we're on the left of 5. We're over here. The word strictly comes up. It means there's no equal sign like there is here. So this is specifically excluding 5. So this is going to be a parenthesis. Notice the parenthesis faces the other way, or an open circle. Okay, so for our interval, now our interval is interesting because as we read from left to right, we're going to end with 5, not begin with 5. So what are we beginning with? Well, this arrow says we go all the way to the left. So if we got to go all the way to the left, it's negative infinity. So that's our interval. And then let's look at our set builder. I'm realizing we forgot the set builder in the previous one, so I will go ahead and do that again. So there's a brace. They're not always as pretty when I'm not paying enough attention. X, the set of all x such that x is less than 5. Woohoo. What I'm going to do is I'm going to go back to the first page. I got so excited about the parenthesis and the bracket, I forgot to write in the set builder notation, the set of all x such that in this case, x is greater than or equal to 5. And then I have a little bit of extra space, so I can show you what the fancy options. I could write x such that x is greater than or equal to 5 and x is an element of the set of real numbers, which is something we assume right now that we're dealing with real numbers, but you could be explicit about it. And then this is not as common, but I have seen it. X is an element of the set of real numbers such that x is greater than or equal to 5. So you're going to see a lot of people do a lot of really interesting things with it. And as you go further in math, you're going to start doing more interesting things with it. But for right now, this is fine. This set builder notation is a fine place to be. Okay, let's go back to the second page. Sorry about that. So let's work on the next one, number 4. How do you pronounce this? You're right. I think you're right. X is less than or equal to 5. Okay, so my graphs are both going to have arrows. I'm going to have 0 because I like to have 0. You could choose another number if you want. We're still on the left side because we're in the less than. Left is less than. It's kind of cool. But only if the x is in that direction. Also, if you notice, if the x is on the left, do you see the inequality points in the direction you go in? I can bring us back to the first page and remind you. See how this arrow points to the right and then we color to the right? If the x is on the left, we're going to follow the pointer of the inequality. So this goes to the right, this one goes to the left. But that's only if the x is on the left, only if it's set up exactly like this. Okay, so what would our interval be here? It'll be very similar to this, but what change will we make? You're right. We're going to start at negative infinity. We're going to go all the way to 5. But what are we doing here on the graph to say x could be included? Or sorry, 5 could be included. You're right. We're going to do a bracket or a closed circle. Woohoo. Let's see if I can thread the needle here. There we go. Okay, and then our set builder notation, x, such that x is less than or equal to 5. Oh, see, as I get tired, my braces start to look like squiggles. I'm sorry about that. I'll try to make them look more pretty. That's really common, though, with math teachers. We tend to be a little tired at the end of the day. Okay. You know, it's hard. It's hard making so many students so miserable. It takes it out of you, really. You know, we need special math therapists who can help us, you know, get our energy back up. You know, we need trainers. Because again, spreading misery the way math teachers do, it seems like it just comes naturally. It doesn't. It doesn't. You have to train for this. This is, you know, hard work. Okay. Arrows, 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 arrows. Everybody gets an arrow. Now, this one is really hard to say in English. People have different ways of saying it. I say -3 is less than x, which is less than or equal to 15. Now, I put the which is in. A lot of people leave that out. So they would say -3 is less than x is less than or equal to 15. So they wouldn't try to make it as English as I try to make it. In other words, we're going to start at -3 and we're going to go all the way to 15. I am not going to put 0 in. As soon as I try to put a third number in, I have to make it like, could I put the 0 right in the middle? No, that wouldn't be to scale. I have to make it closer to -3 than 15. I don't want to measure right now, so I'm just going to include those two numbers, -3 and 15. See how x sits in between them? So that's where our points are going to be. They're going to be in between these two because x is bigger than -3. So -3 sits on the small side, and then 15 sits on the big side. Now, the next question is, what symbols do we put on the -3 and the 15? So is -3 included? No, it is not. So we're going to put in a parenthesis or an open circle. Okay, is 15 included? Yes. See that equal sign? That means that 15 gets a bracket or a closed circle. What do you think? Sometimes people call this a half open or a half closed interval, depending on your perspective. Okay, so what is our interval? Well, in my mind, this interval is the easiest one of all because you don't have to remember infinity. You start at -3 with a parenthesis, and you go all the way to 15 with a bracket, just like that. Again, intervals are going to basically summarize, this is where you start, this is where you stop. So that's what an interval does for you. And then the last thing that we can do, set builder, it's a little bit longer. I'm just going to take this whole thing and put it in there. And the set of all x such that -3 is less than x, which is less than or equal to 15. Is 15 included? Yes. Is -3 included? No. Woohoo. That's it. So in the next video, we're going to learn some rules about inequalities and figure out how it is we can actually use inequalities to start, doing some interesting things. So, woohoo, I will see you in the next one. Here's my poor mouse trying to find the end button. Math on, guys, math on.